Alright, g'day students, this is Mr. Lim again, and we're going to do a video about writing half equations. So, first of all, what do you need to know before we get onto this video? What is required for balancing equations? So pretty much you need to remember that you need to have the same amount of things on either side of the equation, and you need to know the definitions of reduction and oxidation. Okay, so that should be fairly straightforward. You should already know most of those things, and let's get on to writing half equations. So, writing half equations show either the oxidation or reduction process occurring without the other. Okay, what does that mean is that you're showing the gain or the loss of electrons without showing, well, the other process. Okay, it's important because it helps us see the amount of electrons lost or gained during any particular half of the reaction, and it helps us put together reactions when you can have one half equation be applied to many different reactions, and that's why it's useful to write half equations. So the question usually gives you the identity of the reactant and the product that you want it that it turns into, and then there are a couple of steps to follow when balancing out these half equations. Alright, so you have to add water and hydrogens and electrons to balance out the half equations, and there are a couple of steps here, 1, 2, 3, 4, 5. Right, so we're going to go through those 5 steps with a couple of examples, but let's just quickly go through them. You write out the reactants and products. You balance elements that are not hydrogen or oxygen with coefficients. You balance oxygens by adding water to the sides that is lacking oxygen. Balance hydrogens by adding hydrogen ions. And then you balance by adding electrons. So let's go through one of the first examples. Okay, so here we have MnO4- and Mn2+. Alright, so make sure that when you're writing out half equations that you're writing out states as well, and this happens to be aqueous, this happens to be aqueous as well. Okay, so a solution of MnO4-, this is called permanganate, turning into manganese ions. Okay, so first of all we have to follow step 1. Step 1 is to balance out the non-oxygen or hydrogen elements. Okay, so what is the element that is not hydrogen or oxygen here? It is the Mn. Okay, and it happens to be 1 on each side, so that's done. That's step 1 done. Alright, step 1 and 2 done. Right. Step 3 is to balance out the number of oxygens with on this by putting in waters. Okay, so we see here that we have 4 oxygens on the left and 0 oxygens on the right. So since we have 4 oxygens on the left and 0 oxygens on the right, I need to add 4 oxygens to the right hand side here. Okay, adding 4 oxygens to the right hand side, I will need to add water, because that's what I'm going to use to balance out the oxygens. Each water has 1 oxygen, so to balance out the number of oxygens, I'm going to need 4 waters. Alright, so now I've balanced out the number of oxygens. Now I've got to follow the steps, and step 4 is to balance out the number of hydrogens. To balance out the number of hydrogens, I now look, okay, I've got 8 hydrogens over here, okay, the coefficient times the amount of hydrogens in that particular molecule being water, so 4 times 2 is 8, and I have 0 hydrogens on the left hand side. So I need to get 8 hydrogens over to here, and so I'm going to add 8 hydrogen ions. Okay, now I've forgotten to put in states, but you should be able to see that your water is in liquid state, your hydrogen ions are in aqueous state. Okay, so now the hydrogens and the oxygens are all balanced. Now we've got to follow the last step, which is step number 5, which is to balance out the overall charges. Okay, so now this is a little bit easy to get lost, but you've got to make sure that you take into account all of the coefficients and the charges here. Okay, so what you've got to do is you've got to look at how much charge there is on the left hand side. There is a 1 negative here, and there are 8 positives here. So we have a total charge of positive 7. 8 positives and 1 negative makes positive 7. We have a total number charge of positive 2 here, and, well, 0 here because there's no charges on the neutral substances. So we've got a positive 2 here. So positive 7, positive 2. We need to even out this by adding electrons. Now, electrons are negatively charged, and therefore we'll need to add them to the side which is more positively charged. Okay, so the side which is more positively charged is this side. It's plus 7 compared to plus 2. So we need to balance it out so that they are both plus 2. Okay, we're going to bring the positive 7 down to the positive 2. So therefore we're going to need to add electrons in, and we're going to need to add 5 electrons. Okay, electrons don't have a state. And so this is the balanced equation for the, let's have a look. Is this an oxidation or reduction? The electrons are on the left. That's a gain in electrons. So this is a reduction process. Okay, let's have a look at the next one that we've got. Okay, the next one is Cr2O7 2- going to Cr3+. Okay, so let's go try that one out. Okay, so that is Cr2O7 2- going to Cr3+. These are both aqueous. Remember, you've got to put in the states. That's step 1. We've written down what it becomes. Okay, so step 2 is to balance out the non-oxygen or hydrogen elements. What's the non-oxygen or hydrogen element here? It's the chromium. There's 2 chromiums there and only 1 chromium there. So to balance that out, we're going to have 2 of these. Okay, now we've got to add in waters because we need to balance out the oxygens. So I've got 7 oxygens over here and 0 oxygens over here. So I've got to add in 7 waters. 1 water for every oxygen that's over here. Okay, so 7 waters. The next step is to add in hydrogens. I have 14 hydrogens over here and 0 hydrogens over here. So I'm going to add in 14 hydrogen ions here. Alright, again I've forgotten to put in states, which is terrible. And so now I've got to finally add in electrons. So I've got a positive 6 over here. Positive 6 because I've got 2 positive 3s here. And I've gotten over on this side a positive 12. Positive 12 because I got 14 positives and 1 2-, so that makes a positive 12. I've got to bring the positive 12 down to the positive 6, so I need to have 6 electrons. Again, this is a reduction process because we're going to gain electrons on that side. Okay, let's have a look at the next example. The next example is MnO2 goes to Mn2+. Right. So let's go through. Are the non-oxygen and hydrogen elements balanced? Yes, they are. Right. So now we can add in waters to balance out the oxygens. I've got 2 oxygens over there, so I'm going to need to add 2 waters over here. Now I need to add in the hydrogens. I've got 4 hydrogens over here and none over here, so I'm going to add in 4 hydrogens here. I've got a total charge of 4 positive on that side and 2 positive on this side. So therefore I need to add electrons onto this side, 2 electrons onto this side. Let's get to the next example. NO3- goes to NO. Okay, and you'll notice I didn't put in many states over there. That was a solid, that's an aqueous, and this is an aqueous as well. Okay, this is an aqueous, and this is a gas. Alright, so the non-hydrogen and oxygen elements are balanced, the ends are balanced, so I need to add in some waters. How many waters do I need to add? I need to add in 2 waters on the right hand side. I then need to add in how many hydrogens? 4 hydrogens on the left hand side. And then I need to add in how many electrons? 3 electrons. Okay, I had positive 4 and negative 1, So it makes positive 3, and I have 0 on this side, so I need to bring this down to 0, so I need to add in 3 negative charges there. Alright, let's try the next one. H2O2 goes to H2O. Alright, I've got to balance the non-oxygen and hydrogen elements. There are none. I've got to balance out the oxygens. So I've got to balance out by adding another water over here. Okay. And then I've got to add in some hydrogens over here. And then some electrons over here. Okay. You're not always going to have reduction equations. It just seems to be that we've written down lots of reduction equations. All right. And let's go to the next one. VO2 positive goes to VO2 positive. Okay, so notice I said that the same way. VO2 positive and VO2 positive, but they are different things. Okay. Just depending on where the value is. All right. Add in a water. Add in some hydrogens. And where do I add the electrons here? On the left or on the right? Positive 2 on this side. Positive 3 on this side. So I need an electron over here. Okay. Let's try. Now we have to talk about in an alkaline solution, because the next two questions are about an alkaline solution. So let's go back to the Word document. So, if you're doing yours in an alkaline conditions, and it tells you that you're in alkaline conditions like these two here, alright, you need to add a step 6. You're going to add hydroxide ions to both sides to turn hydrogen ions into water, and then you're going to have to cancel out everything. So let's go have a go. So we've got Cr2O7 2 minus goes to Cr04 2 minus in alkaline solution. So let's practice that. Cr2O7 2 minus goes to Cr04 2 minus in alkaline conditions. Okay, so first of all I've got to balance out the non-hydrogen oxygen elements, which is the Cr. I'm going to put a 2 in over here. So now I think, how many oxygens have I got on the left? I got 7. How many oxygens on the right? I got 8. Which means I need to add a water over here. How many hydrogens I got on the left? 2. How many hydrogens do I need to add on the right? 2. So now I think, what's the overall charge on the left? 2 minus. What's the overall charge on the right? 2 times 2 minus is negative 4, plus 2 is 2 minus again. Oh, this is an example of something that isn't actually a redox reaction. Okay, how do we know this? Well, first of all, the two charges are the same. Overall charges are the same. And then we can even go further and check. Okay, let's check the oxidation number of these two chromiums here. Okay, here, the chromium, the oxidation number for this chromium is, right, we know that it's negative 2 is the total charge on the positive ion. We know that there are 7 oxygens, so that provides 7 times negative 2. And we've got to work out what each chromium is going to be. Okay, so 2 times the chromium, which we've designated as X here, plus 7 times the negative 2 there is equal to negative 2. Right, so this is negative 14. This is 2x. Right, well, we got 2x is equal to, what's that? Positive 12. And x is equal to 6. Positive 6. Okay, now we've got to do the same over here. Negative 2 is equal to 4 times negative 2 plus one of these x's. Okay, so this is -8, and that's x, that's -2. Right, again, x is equal to +6. So if there's been no oxidation number change, oh no, you haven't been able to see that. There's no oxidation number change, not a redox reaction. Right? Well, let's try the next one. Hopefully that's a redox reaction. Okay, so let's have a look. Bi2O3 goes to BiO3 minus. Okay, so again, we're going to balance out the non-oxygen and hydrogen elements, which happens to be Bi. Put a 2 in front of there. So then you've got to add in waters to balance out the oxygens. I've got 6 oxygens here and only 3 oxygens there, so I'm going to have 3 waters on this side. I'm going to then have to balance out the hydrogens by adding 6 hydrogens on this side. Then I say to myself, okay, what's the total positive charge here? Total charge here is 0. Total charge here is +4. So we're going to bring this +4 down to 0. So we add in 4 electrons here. Okay, 4 electrons here. Now we've got to do this in alkaline conditions. Okay, so we've got to then add in hydroxide ions to neutralize the H+ ions here. So if I've got 6 H+ ions here, I'm going to need to add 6 OH- ions. And because we're doing this as a balanced equation, I need to put in the 6 hydroxide ions over here as well. Now these 6 here and these 6 here are going to form 6 waters. So this really ends up as 2BiO3 plus 6 waters plus 4 electrons. And on this side, it equals to 6 OH minus plus Bi2O3 plus 3H2O. Now you'll notice that we can cancel out these, or at least some of these, so we can cancel out all of those, and we end up with 3 of those. And that's how you would do it in alkaline conditions. 6 OH minus here, and the Bi2O3 then goes to 2BiO3 plus 3 waters plus 4 electrons. Okay, and that's it. All right, in the notes, it does talk about, for organic reactions, there is a different set of ways of working out the reduction equations or the oxidation equations of organic reactions, and we'll go through that in a different video, but that's the basic steps. You've got to remember these 5 steps for writing out half equations. And that's it.